ওকে, গুড মর্নিং গাইস। শুভ নববর্ষ সকলকে। আজকে যেহেতু শুভ নববর্ষ, সবাইকে বাংলায় একটু উইশ করে দিচ্ছি আমি। শুভ নববর্ষ সকলকে। সবাই আশা করি সুস্থ আছো, সুস্থ থেকো, কারণ এখন যা সময় সুস্থ থাকাটা খুব দরকার, সুস্থ থাকতে হবে। আচ্ছা, so in the CAD lab today we will discuss how to create floor load in range. We have to specify the range. Okay, so consider we are creating this type of grid today. In this grid, this is the, all right, okay, this is the staircase portion. As you know, in the staircase portion there will be no slab, there will be no slab. So in the staircase we do not give slab. We are making a 3-story building. Consider we are making a G plus 3-story building, G plus 3-story building, and we do not have any slab in the staircase. We have to make that. Okay, now consider, so in this portion, there won't be any slab. Only there will be a slab, there will be a slab, there, there. So this portion will be a slab, but this portion won't be any slab. So we have to give a range. We have to use the range system today. How to do that? Let me show you how to do that. Okay, so okay, we are opening a stat now. Okay, we are opening the stat. Let us open the stat. Space structure we are creating. So today's structure will be floor load with grid. Okay, unit is same. We are creating a beam structure. So today it will be a irregular structure that we know. A irregular structure we have to create. So first, so change the grid, create a new grid, irregular, naming the grid 1. So let us see the x coordinate. Let us see the x coordinate. So this is our x and this is our z. Okay, this is our x and this is our z coordinate. So x coordinate, what is the grid points? 3.5, 4.2, 3.7. So putting the grid point here, 3.5, 3.2, 4.7 in the z x coordinate. And what is the z coordinate? 3.1, 4, 3.85. So 3.1, 4, 3.85. Okay, so xz plane we are creating because it's a slab structures we are creating in the xz plane. Okay, so name is given. Okay, it is done. Choosing the irregular grid, done. So now you have to create the irregular grid. So on any, don't create a node over another node, putting all the nodes here. Okay, done. Create beam, join all the vacant positions here, like that. Join all the vacant positions like that. Okay, so grid portion is created, I think. So let us go to general. Now we have to create one G plus 3 building. So consider this is the G point, this is the G. We have to create plus 3. So G plus 3. So take all the points, nodes, y direction. Consider 4 to 4 distance is 3.125. Okay, link all the steps. Step number 1, 2, 3. Okay, oh, sorry, 3, G plus 3. Okay, so all the points are created. The lower portion will be the foundation, so lower portion is deleted. So we have created the G plus 3 building. Let us give the support systems. Create fixed support system we are creating. So let us choose the grid points and give the support there. Yes, supports have been given. Okay, now section property. Let us try one normal section, beam, a column section, normal rectangle, ZT 0.35, 0.25, add, and another one will be ZT 0.3 and sorry, and 0.3 and 0.35, add. So this is beam. So select beam parallels to X and beam parallels to Z, because beams are always parallel to the X and Z portion. Assign to selected beam, yes. Beam parallels to Y, take it and select. Beam parallels to Y, always will be the columns. Okay, all are done. Let us take a 3D diagram of the total structure. 3D diagram has been created. Okay, the building structure has been created. Let us move to the load. So load structure. Now let us come to the picture again. So load, consider the floor thickness. All right, load thickness, load thickness 150 mm. Consider we are creating a floor thickness of 150 mm. So what is the load that is coming from the slab to the beam? What is the floor load will be created? Floor load that we have to do is that I have told you in the earlier last class, that the floor load that would be created is floor load equals to density of the concrete, that is 25 RCC kilonewton per meter cube into 0.15. Okay, this is the value of the total floor load. What is the value will be coming? Calculator, 25 into 0.15, I think it is 3.75. So we are getting floor load value equals to 3.75. We are getting the value of 3.75 kilonewton. What is the unit will be? Kilonewton per meter square, because the density is in kilonewton per meter cube, so the unit weight will be kilonewton per, so the load coming to the unit kilonewton per meter square, because 0.15 in meter is multiplying with 1, so 3.75. so we have to put the value. So let us go for the loading. So load and definition, load case details, add, you only load, no load case, so load in range, we are giving the load name, add. So in between that load we have to create the range. Okay, first, so floor load, coming to that. Now wait, listen very carefully, this is the next part. Now floor load, what is the pressure is coming? Floor load we have gotten 3.75, unit will be minus 3.75, as it is acting downwards the gravity, downwards the y direction, so it is minus. Now coming to the, so global y direction we are giving. Now very much important portion, in the y direction all these three floors will be having the load. So what is the node to node distance from y direction? 0 to 9.375. so minimum direction y direction 0 and maximum y direction 9.375. why? That is the question. Now comes the question, why? Because minimum means the starting point of the load. This is the starting point of the load and this is the ending point of the load. That means ending point of the load means in between that the number of the slabs, it will give the value of the load. In between that, in the y range, in between that all the slabs in between that will be given the amount of this load. This is the basic funda. So in between that there are 1, 2 and 3 slabs. So in between that, as there are 3 number of slabs, so for 3 numbers of slab, all the slabs will be loaded. Now if it is consider from here to here, only these 2 slabs we have to give, not all that. Moving, consider from this to this, we have to give the load. So it will be 6.25 will be the maximum value, because this is the 0, this is the minimum value, this will be the maximum value, this is the y. Now we are assuming the total section, so we are assuming from here, we are assuming from here to here, this is the y direction, because 3 floors will be loaded, all the floors will be loaded. Now coming to the x and z direction, let us change the view. Okay, in the x direction from here to here. Okay, okay, now in the x direction, there will be no floor here, there will be no floor here. So only this, 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 this will be created. Now from here, this is x-axis, from here this is z-axis. So defining the range. So for this slab from here to here, this is one part of the slab. So here the starting point is 0, because from here the load is starting. So this is the starting point of the load. Okay, from here to here, what is the ending point of the load? Let us try a node to node distance. Let us try a node to node distance here from here to here. What is the node to node distance? Distance is 3.50. So from the x range, minimum value will be 0, maximum value will be 3.5. Maximum value will be 3.5. Now, so we are creating, all right, let us take this color. Okay, so we are creating, so this will be no floor, there will be any no floor, and only, so from here to here we are covering this part. So x direction we have covered, x direction, x range we have covered. Now coming to the z range. So z range will be from here to here. Here the z range, z equals to 0, and here z equals to from here to here, z equals to 10.95. So if we take that, so here from here to here, this is z equals to 0, and from here to here z equals to 10.95. So if we give the value of the z range here, so the minimum range will be 0 and the maximum range will be 10.95 in the z range. That means from here to here the load will be acting, and the x range, it is 0 to 3.5, so here to here. So all this range will be loaded, not extra from there, only this plate will be loaded. So let us put the values. Yes, so x range, so z range will be 0 to 10.95. okay, so let us check if the load is acting or not. Add, close. So if we see the whole structure moving the values, so we think all the slabs in this range are loaded. Okay, this is our required thing, only this slab. Similarly, we have to create, again coming to the top view, again we have to create load for this slab, and this total slab in one direction. Considering we are creating now this total slab. So what is the x range here? So from here, so this will be the minimum distance, this is the minimum distance, and this is the maximum distance. And z range is similar here, this is the minimum distance and this is the maximum distance. So let us create the point. So this is the minimum distance here to here, and this is the maximum distance. So from here to here, the x direction, the load will be created from here to here, and from the z direction, total direction we have to take from here to here. Then only this portion will be loaded. This portion will be loaded only then. So x range will be that value and that value. So this is the value. Okay, so this value is for that portion and this value is for that portion. So, and this value is for that portion. So, what will be the range of that load? Now, coming to the load criteria, again we have to add another load, floor load, like that. Okay, so let us put the value, same value will be there, similar load 3.75, range y range will be 10 to 02. What was the height of the building? Let us check the height, 9.375, 9.375. Now the x range, minimum value will be 6.7, maximum value will be 11.4. Z range, minimum value will be 0, maximum value will be 10.95. Okay, so this is the value of the x and z range. Add. So let us check the value is coming or not. Let us check the value. So we think this value is also created. Now the remaining part we have to create. What is the remaining part here? The remaining part is that portion. Remaining part is that portion. Okay, let us move. Remaining part is that portion, so let us move first the distance to distance. So now we have to create the portion for these two portion. One portion will be that portion and another portion will be that portion, because this portion is the staircase, this portion is stair. So we will not create that. So another one portion will be that and another portion will be that. Now when we are creating these two portion, a continuous portion cannot be applied. X portion will be same. This is the minimum x range and this is the maximum x range. And now x portion is created in between that two values. So for these two panels, x value is same, x range is same, but y range will change. So minimum for that value, this is the value of the y range, and for that value this is the value of the y range. This is the value of the y range. So this value we have to take. I think it is clear to you. Okay, so from here to here x value and from here to 2 z values will be taken, but the x value is same. So 2 extra panel load we have to create. How to do that? Let me show you. So let us first define the range. What is the distance of the range? From here to here it is 3.1, from here to here it is 7.1, it is here to here it is 10.95. So from here to here for this panel, this is the x range. Okay, this is the x range and this is the maximum x range when we are getting the value of these 2 points. Okay, this is the x range and this is the y range. Okay, and so here so as I am showing, so this is the starting x range, this is the ending x range. So 3.5 this value to be here and 6.7 this value to be here. Okay, 6.7 this value to be here. Now for that part z value, so 0 is the z value, so and 3.1 is the another z value here. So 3.1 will be here and this value is 0. So minimum range will be 0 and maximum range will be 3.5. and now for that section, minimum range, this is the minimum range and maximum range. Minimum range will be 7.1, that will be the minimum range, and 10.95. all right, 10.95 it will be the maximum range. So 10.95 is the maximum range, 7.5, 10.95. So these are the ranges. So let us put the values here. So first one load, add floor load value 3.85 minus 3.75, that is the value of the load. Now coming to the x and z range. Y range is I think 9.375 first range. So x range value, minimum value is 3.5 will be the value, maximum value will be 6.7. Similarly z range, minimum value will be 0 and the maximum value will be 3.1 for only this slab. Okay, So creating the load, add, and for the second portion the x range will be same 3.5 to 6.7, but the change will be in the y direction, that is the z direction, sorry. 7.1 will be the minimum range and maximum range will be 10.95. Okay, so this is the minimum range. So add. So let us check the values here. Let us check the values. This load, okay, only this load, and this load only this load. So the loads are being created. If you see it, you can see that, all right, if you see it, you can see that no load has been created for that portion. So the staircase portion is left out, so there is no load that has been created in the staircase portion. So let us analyze the section. Analyze, okay, analyze, add, no print data, close. Let us analyze the section, run analysis, save. The section will be analyzed now, as you know. So there is no zero error, zero warning, one note is not necessary. So this is the bending moment diagram. Changing the scale, it will come to that. Changing the scale, it will come to that, like displacement value. This is the flow load acting, that's why the reflection is coming like that. This is the reflection values. Okay, this is the reflection values. This is the bending moment diagram. Okay, let us similarly change the scale. This is the bending moment diagram. Similarly, the shear bending y direction is also there. You can check it. Shear force diagram is there. This is the shear force diagram Fy. So this is the shear force and bending moment diagram. Okay, so that's how a beam, a floor grid with any part can be left out in a building. There can be more than one part, there can be more than two parts. Any parts can be left out in the building by defining the ranges. So this is the usefulness of range. So in the building design, there will be a staircase, there will be lift lobby, etc. There will be sometimes there is no floor in a grid. So for that cases, we need that concept of the zone. So this is very important part. Okay, so please practice this creation of this type of ranges by yourself. If you have any question, you ask the question to me. Okay, so for that today, for this is for today. Hope you are all okay. Stay home, stay safe. Thank you very much for your time, guys.